Alright, on this lesson we're going to be solving radical equations. First thing you do, get your radical or exponent expression isolated on one side. Then you're going to cancel out nth roots by raising both sides by the nth power. Exponents can be canceled by raising by the reciprocal. You're going to see both these in the examples. You do want to always check solutions because you can have extraneous solutions. I'll show you a case where that does happen. Alright, first thing, let's go ahead and take a look at this first problem. Square root of 1 minus x equals 7. So since it's already isolated on one side with the radical, you are ready to raise both sides by the second power. The reason why I'm doing that is this is the second root. So once I raise both sides by the second power, that's going to cancel with the root on the left-hand side to leave you with 1 minus x. 7 squared is going to be 49 over here. Now I'm ready to just actually subtract 1 on both sides to have negative x equal to 48, and then divide by negative 1 and we'll wrap up this problem. So positive x is equal to negative 48. Now before you say that that's a good answer, you do want to check your answer by typing the original expression into your calculator. So square root of 1 minus the x I found to be negative 48, so I'm dropping that in. And when I hit enter, I do get 7, just like I'm supposed to, right here. Now, I'm ready to say that that's my answer. Move on to number 2. Alright, on number 2, since it's the cube root, what I'm going to do at the beginning is cube both sides to cancel out the cube root. So that will be 5x plus 1 now equals negative 4 to the third power. So that's definitely something you can use your calculator for. Negative 4 times negative 4 times negative 4. I made a mistake there. So I did actually forget to type in the third power. And that'll be negative 64. Alright, now I'm just going to subtract 1 from both sides. So 5x will equal negative 65, and divide by 5. X will equal negative 13. Yet again, we do need to check these answers. So I'm going to hit the math key, go down to cube root of 5 times negative 13 plus 1, and hit enter. And I'm going to get negative 4, just like I should have. This is a good answer. If ever it's not, it's an extraneous answer, and you do not include it as part of your solution set. If it's the only one you got, you would say no solution. Alright, on number 3, the difference here is that you have to isolate the root first. So you're actually going to do the steps of subtracting 6 from both sides. So you're going to have 1/4 times the 4th root of 2x equals 4. And you're going to divide by 4, or sorry, you're going to divide by 1/4. I would rather just multiply by 4 on both sides to cancel out the coefficient of 1/4. So that's going to be the 4th root of 2x equal to 16. Now I'm finally ready to cancel out my root by raising both sides to the 4th power. So 2x would equal 16 to the 4th power. Now as far as doing 16 to the 4th power, 16 to the power of 4, definitely not doing that by hand, 65,536. Then I just got to divide both sides by 2. So hit divide by 2 in your calculator. We'll divide that previous answer by 2, and 32,768 is your answer. This does work when I type it in. So typing it in, 1 divided by 4 times. Now to get 4th root, you hit the math key, and it is the 5th option down, x root. So now I can type in the 4th root, arrow to the right, 2x as my radicand, but we're typing in 32,768 as my x value. And then I'm going to hit the right to get out of the root before hitting plus 6. When I hit enter, I do get 10. This was a good answer. Alright, number 4, I'm actually not going to do on this video. Number 5, this is where things start to get a little interesting here. So what's going to happen is the root is by itself already, so I am going to go ahead and square both sides. What throws most people off on squaring both sides is squaring the x minus 7 correctly. So that's x minus 7 times x minus 7. And when you do that, that's actually going to be x squared minus 14x plus 49 equals, and now the root and the square just cancel over here. If you're a little lost on this left hand side, you need to go back to perfect square trinomials when we were simplifying those. Now, this is a quadratic equation. I would totally get it equal to 0 by subtracting x from both sides and adding 5 to both sides as well. So I'd have x squared minus 15x plus 54 is equal to 0. You could use your graphing calculator to solve this. I'm quickly just going to factor it because x minus 6 times x minus 9 is the factors for that expression, and set both those factors equal to 0. So here x equals 6 or x equals 9. Now it is possible for you to have two solutions on these equations, so both of these might be correct answers. However, one of them ends up being an extraneous solution. So if I try to plug these back into the original, and I'm going to do this on my calculator, so I'm going to do 6 first. I'm going to do 6, take away 7, and that's negative 1. And then if I do the square root of 6, take away 5, that ends up being positive 1. Because these two answers ended up not being the same value as they should have been equal right here, I know that this is an extraneous solution. I'm not going to include 6 into my solution set because it doesn't work as a solution. However, when I try out 9, take away 7, the left-hand side of the equation, I get 2. And when I do the square root of 9, take away 5, I get 2 as well. So that is a good answer. If everything cancels out as extraneous, then you've got no solution. Next up is exponent expressions. So what's going to happen here is I'm going to get the x to the 5/2 by itself by canceling out that 1/2, and I'm going to do that by multiplying both sides by the reciprocal, 2 over 1. So now I would be left with x to the 5/2 equals 16 times 2 would be 32. Alright, now to cancel out the exponent, what you're going to do is you're going to use the reciprocal there as well. So the reciprocal of 5/2 would be 2/5. So I'm going to raise both sides by the 2/5 power. So x would equal, the reason why that cancels, 5 times 2 would be 10 over 10. 10 over 10 would be x to the first power. 32 to the 2/5, definitely something that you can use your calculator on if you feel more comfortable with that. Can be done by hand, but I'm not interested in teaching that in this lesson. So x equals 4. Now this does work, but you would want to go back and check your answer. So type in 1/2 times 4 to the 5/2. It does give you 16, but we're going to move on knowing that that's the case. Here, you do actually need to subtract the 28 first, right off the bat, before getting into this one. So I'm going to have 6x plus 10 being raised to the 7/3 equals, and then 156 minus 28 ends up being 128. Alright, now I'm ready to cancel out my exponent. Since it's 7/3, I'm going to use an exponent of 3/7. Definitely going to use my calculator here. So 128 to the 3/7 ends up being 8. I would be left with just 6x plus 10 on the left-hand side. So now I'm going to subtract 10. So 6x will equal negative 2. And divide by 6. X will equal negative 2 over 6, but you know that you need to reduce any fractions. Negative 1/3 is your best answer here. Alright, and like I said on the last one, you should check your answer. I will actually show checking this one since I kind of did not on that previous one. So 6 times negative 1/3 plus 10. I'm going to close those parentheses. Now I'm going to raise it by the 7/3 power. And then I'm going to hit the right-hand arrow to get out of the exponent before hitting plus 28. And when I hit enter on all that, 156, which lets me know this was not extraneous. It was a good answer. All right, for my last problem there, I covered it in class, but I'm not going to do so here on the video. Let me know if you have any questions, folks. Thanks.